Hey everyone, so today we've got something a little different, something fun. We're going to see if you can solve math problems that were literally designed for a 7-year-old. And these aren't just any problems. They're from a second grade math Olympiad prep book.
You know the old saying, right? But let's be real. Are you? Well, we're about to put that to the test. And just a heads up, no calculators allowed.
Okay, so we're going to start with the absolute basics. The building blocks of math that 7-year-olds need to get down cold before they can even think about tackling the really hard stuff. First up is something called place value. It's this simple but honestly super powerful idea that a number's worth changes depending on where it is. Is it in the ones spot, the tens, the hundreds? Getting this is absolutely crucial for everything else we're going to do. All right, here we go. Challenge number 1. In the number 381, what's the place value of that 3? Take a second, lock in your answer. And the answer is 300. Because that 3 is sitting in the hundreds place, its value isn't just 3, it's 3 times 100. See? Simple enough? Let's keep building on that. So expanded form is pretty much the next logical step after place value. It's all about breaking a number down to show the real value of each part. So like 235 becomes 200 plus 30 plus 5. It literally shows you what the number's made of. Okay, so let's try it out. Here's your second challenge. What is the expanded form of the number 235? Yep, you got it. It's 200 plus 30 plus 5. I hope you're feeling good and warmed up because we are about to leave the shallow end of the pool. Things are going to get a bit more complex. Okay, so now we're shifting gears. We're moving away from just looking at numbers to actually using them in word problems. And this is where it gets tricky, because it's not just about knowing how to add or subtract, it's about figuring out what the question really wants from you. Let's set the scene with a little story. So Rena has 4 boxes of sweets, 5 in each box. Simple. But then she gives 10 of them away. You see what's happening? This isn't just a one-and-done calculation anymore. There's more than one step here. So here's the question. How many sweets does Rena have left? This is where that problem-solving part of your brain has to wake up. You've got to figure out what to do first, what to do second. The order really matters. And the answer is 10. See, the key was the order. First, you had to figure out the total number of sweets she started with. That's 4 times 5, which is 20. Then, and only then, do you subtract the 10 she gave away. That leaves you with 10. All right, for this next section, we're going to look at how these math skills actually show up in the real world, or, a second grader's real world. We're talking practical stuff like money and spotting patterns. So here's a classic situation. You're shopping. Atool's buying some sports gear. We've got 3 different items, 3 different prices, and oh, look, we've got decimals in there too. This is going to take some careful adding. So, what's the final bill? How much did he spend in total? Try to add them up in your head. 55 plus 2250 plus 3650. Go ahead, I'll wait. The grand total comes out to 114 rupees. And let's be real for a second. That's not exactly easy math for a 7-year-old. You got to line up the decimals, carry the numbers. That's pretty impressive stuff. All right, it is time for the final challenge. We're calling this the Olympiad Gauntlet. It's a rapid-fire quiz, 3 questions, back-to-back, pulled right from a sample test paper. Let's see how you do under pressure. You ready? Question 1. It's a place value puzzle. You've got 9 ones, 6 tens, and 8 hundreds. Put those pieces together in the right order. What number do you get? Question 2. We've got 21 shells, and they're being split evenly between 3 students. How many does each kid get? This is just a nice, clean division problem. And here it is, the final question of the gauntlet. Take a good look at this pattern. 1, 11, 21, 31, 41. What's the very next number? And a little warning, watch out, this one might be designed to trip you up. Okay, pencils down. Let's see the answers. For question 1, it's 869. For question 2, 21 divided by 3 is, of course, 7. And for that tricky number 3, the answer is D, none of these. It's a trick question. The pattern is just adding 10, so the next number should be 51, which wasn't an option. Ha ha ha. That's a classic Olympiad move right there. So, come on, be honest with yourself. How many did you get right? A perfect score? It's surprisingly difficult, isn't it? These questions, they really make you focus and have a crystal clear understanding of the basics.
And that really gets to the heart of it. This stuff isn't just about memorizing your times tables. It's really about teaching kids how to think logically, how to break down a problem into smaller parts, and how to spot patterns. I mean, these are the fundamental skills for thinking, way beyond just a math class.
So it kind of leaves us with this big question. What does it really mean that we expect 7-year-olds to be working at this level? It's obviously more than just numbers. It seems like we're trying to build a foundation for critical thinking right from the very beginning. It's definitely something to think about. Thanks for joining me for this one.